So this video is on dilations, and if you remember, we've talked about 4 transformations: translate, rotate, and reflect. Those are all rigid transformations, but a dilation is not a rigid transformation. And that's because it changes the size of your shape. The shape doesn't stay rigid. It either grows or shrinks. So the word dilate means to stretch or shrink. To stretch or shrink a figure. It either gets bigger or gets smaller. Think about, like, if anyone's ever been to the eye doctor and had your eyes dilated, your eyes literally will get really big or really small. So true or false, a dilation is a rigid transformation. Like I just mentioned, that is false. It's not rigid. The shape doesn't stay the same size, it changes size. So if you dilate something by a scale factor less than 1, then your figure gets smaller. That makes sense. Like, let's say I take one of me and then I scale me by a half. So if I took like 1/2 of myself, I would be a lot smaller. If your scale factor is greater than 1, then your figure gets bigger. So let's say I do like twice myself, then I would be really tall. So if your scale factor is bigger than 1, then it gets bigger. Just common sense there. So for example, if I were going to dilate this segment AB, by a factor of 4, what's the length of the resulting segment? Don't overthink this. If you were going to take something that's 10 centimeters long and scale it by a factor of 4, you literally just multiply it by 4. Imagine it grew 4 times bigger, so you literally do times 4. 10 times 4 is 40 centimeters. Or if you dilate segment AB by a factor of 0.5, what's the length of the new segment? Again, in this case, it's going to get smaller because the factor is less than 1. This is 0.5 or 1/2. So basically, you're just going to take half of the segment, or half of the segment. So 10 centimeters times 0.5, which is a scale factor, is just 5 centimeters, half of 10. If I want to dilate this triangle by 2, what might that look like? Just go ahead and think about that for a second. Basically, each of these lengths is going to grow by 2. So like this is going to get twice as long, and this is going to get twice as long, and this is going to get twice as long. So that's one option. But there's another way I could have drawn this. So basically, let me see here. Basically, what if instead of growing out from the center, what if I had my center of dilation be right here? So as I stretch the shape, the first one that I drew came out from the center. It grew twice as big, just kind of in all directions. But what if instead I had my center of dilation, kind of the growth point, be right here? In that case, this length would still get twice as long, it would just grow that way. And this would still get twice as long, it would just grow out from that point. And this would also grow out from that point and be right here. Notice that I get the same size triangle, just in a different location. So it matters where the center of dilation is. You're going to get the same triangle either way, but anytime you dilate, the center is kind of like the point from which it grows out of. And it doesn't have to necessarily be the center of the shape. Here's how you can find the center of dilation if you're not sure. If you connect a point from the image to a point to the point in the pre-image, you end up with these lines. So like image to pre-image and image to pre-image. Notice they all actually intersect right there in the center of dilation. So if you ever need to find the center of dilation, you just connect the image to the pre-image through each of the points, and those lines will intersect at the center of dilation. The same thing will work if I do the blue triangle. So if I connect the image to the pre-image, the image to the pre-image, and the image to the pre-image, in that case just this point, notice they all intersect right there at that center of dilation. Let me show you this on a coordinate grid. So for example, I want to graph the dilated image of triangle JKL using a scale factor of 2 and 0, 0 as the center of dilation. All right, so all you actually have to do is take the coordinates and multiply them by the scale factor, just kind of like we were doing before. So if this is 1, 1 currently, and I'm scaling it by 2, then the new version, well, let's see, that was K, so 1, 1. Just multiply them both by a 2, basically. So you get 2, 2. And if J was originally 2, 1, 2, 3, 4, just scale those both by a 2, so like times 2, and you get 4, 8. And if L was originally 4, 0, multiply those by 2 and you get 8, 0. Okay, let's graph these new points. So 4, 8, 1, 2, 3, 4, 5, 6, 7, 8. That's J prime. And K prime's at 2, 2. It's okay, this kind of overlaps a bit. And L prime is at 8, 0. So there's my new triangle. Just connect the dots. Notice that the center of dilation was the origin, and so it grew to be twice as big, but it kind of pushed away from that center, away from that center of dilation. It grew kind of out from there. And this should be twice as long as that. This should be twice as long as this. That should be twice as long as this. And just like I mentioned before, if you connect each point to the original, it should go straight through the center of dilation. Same thing here, same thing here. See how they all meet up right there at the origin, the center of dilation. So here's kind of an image of that. Again, to find the center of dilation, just connect the image back to the pre-image and continue those lines until they all intersect. That gives you the center of dilation. Side note, what was the scale factor for this one? So you may have said the scale factor was 2, which it could be. If we went 6 to 12, that's times 2. 4 to 8 is times 2. But in this picture, you don't actually know which is the pre-image. This could be the pre-image, and that could be the new image. So a scale factor could have been 1/2, just by the way. We're not sure, that's fine. All right, so like on this one, find the center of dilation. Go ahead and pause and try this on your own. Here's the pre-image and the image. To find the center of dilation, just connect C to C prime. And connect A to A prime. And connect B and B prime. And it looks like the center of dilation, if I keep going with those lines, is going to be point D. So point D is the center of dilation. Ooh, that line is so crooked, sorry. But you get the idea. On this one, we want to find the center of dilation. So again, just connect each of the image and pre-image points. So like connect C with C. That pretty much tells you what it is. Connect B prime and B. Connect D prime and D. Connect A prime and A. So on this one, the center of dilation was point A. And that makes sense because it kind of it like grew out from point A.